So let's look at our various options here. First of all, I'm going to suggest every time the first step you should do is factoring. And then the next step you should do is exclusions, things that can't be. Okay, so factoring, you'll see that this is a square, and this is a square, and this is a minus, and this has a square root of z, and this has a square root of 2. So it factors out to z plus 2, z minus 2. This is called a difference of two squares. This one here has a 6 in common, so we're able to factor out 6 and get z plus 2. And then everything else is pretty much the same. So let's start with that. Let's replace the factors we know. We know it's going to be a z plus 2, a z minus 2, and we know over here we're going to factor a 6, and we're going to get z plus 2. We're going to instantly notice, oh, z plus 2, z minus 2. There's going to be some cancellations along the way. And we'll replace what we know. Right away, we can do some exclusions. Z cannot be 2 or minus 2. And so far, that's the only exclusion. Z can't be minus 2 here, minus 2 here, and 2 here. That's the only exclusion so far. So we have two different techniques. I'm going to show you all of them, and you have to decide personally which you find easier. Mine is to say what's in common in both of these, z plus 2, z plus 2, and focus on what's not. So there's a z minus 2 here, but there's no z minus 2 here. There's a 6 here, but there's no 6 here. Ignore the right side for now. It won't matter. But we're going to start with the old school method, which is cross multiplying. And you can see right away, it gets pretty complicated. First of all, when the denominator, when we do the final one, denominator times denominator, we can just put them all beside. And generally, they put the numbers in front. So after I'm done cross multiplying this way and this way, there's this way, and this is what you end up that way. So I'm just doing that way first, and that's what I end up with. And you just leave it like that. You put a long bar up here. But over here, we got the 2, and it's going to be multiplying by, and I'm just going to make a copy of this and get rid of my, there we go, like that. We're going to cross multiply this with the 2. Right? And then we have a plus symbol in between. We got this 10. And it's going to cross multiply with this. We've cross multiplied, and we just keep the right side. When you cross multiply, you don't have to do anything to the right side. But you can see that it's pretty damn messy. You might want to say, oh, the 6 can cancel with a 6, but no. This plus here means this whole thing is married as one group. And you can only cancel things at the bottom if it's in brackets of both at the top. Now, that's the secret. As an example, I can see z plus 2 is in this, multiplying that and that. And I can see z plus 2 is here, multiplying that and that. So conceivably, on the top, I could factor out a z plus 2 from both of them, and I'd be left with this. This would allow me to cancel with this z plus 2 down here. Or if you want to just save that constant factoring effort out, you can instantly say, well, because there's a z plus 2 in this one and in this one, I know I could factor it out and it could cancel with the bottom. So instead, I'm just going to factor out one here, because you got to do one in each of the pluses, and only one here because it's all multiplying. So essentially, something that's being plussed, I can only factor out if it exists in both. It does. I could have factored it out and then canceled, or I could just say, well, there's one there and one there and one here, so I'm going to factor them all out. This here, 2 times 6, we might as well represent it as a 12. So far I've got 12 plus 10, z minus 2. There's a z minus 2 in this one, but there's none in this one, so I can't factor it out. There's a 6 in this one, but there's no 6 in this one, so I'm just going to leave it. So you can see that it's already gotten complicated with this cross multiplying, and it's not any clearer what I have to do. I do know now, though, so this is the top, 10 times z minus 2. I could expand it and all that, and maybe I should. I think I will. So 10 times z, 10 times minus 2. I get 10z minus 20. And I can see I have 12 plus 10z minus 20. So I can just say, well, what's 12 minus 20? I can rearrange it. It's minus 8. So I have a minus 8 here. 10 minus 8 plus 10z or 10z minus 8, however you want to write it. Whenever you want to get rid of a denominator, you can treat it as one giant denominator. And since it's all multiplying, you could expand it, but I'm going to suggest you don't expand it. So if I want to get rid of that that denominator, I simply multiply it by its reciprocal. Right, I'm going to move that 6 closer. But if I multiply it on the left side, I also have to multiply it on the right side. There we go. And I can see right away when I do that, well, this is the same as this, so they cancel out. That's why I did it. And I can see up here, I can ignore this 1 because 1 times anything is just the anything. So really I have that thing up top divided by this thing at the bottom, and I can see they're all multiplying. 6 times that bracket times that bracket. That means this bracket can cancel with this bracket. And good, now I just got to expand it. 6 times z, 6z, 6 times 2 plus 12. So cross multiplying here was okay. A little bit confusing on what to do and how to do it. And then I got to get all my z's on the one side. So I got 10z. So I'm going to bring this 6z over by subtracting 6z to both sides. So I get 10z minus 6z. And it's essentially going to cancel out on the right. And this minus 8 on this right side, I'm going to add plus 8 to both sides. It'll cancel it on the left. And I'm left with 12 plus 8 over here is equal to 20. And then this 10z minus 6z, of course, is 4z. And I think I got it wrong in our thing. I got 4z. And then to solve for z, I divide both sides. Or if you might want to also get in the habit, instead of dividing both sides by 4, multiplying them by the reciprocal, 1 over 4. It cancels here. 20 divided by 4 is 5. So z is equal to 5. To verify if z is indeed 5, and I think I got the wrong answer yesterday, you would go back to the original equation, and put in 5 wherever you see z. And I think I had the wrong one yesterday. So I can see here 5 squared, 25, minus 4 is 21, 2 over 21. Plus 10 over 6 times 5, 30, plus 12, 42, is equal to 1 over 5 minus 2, 3. So I have to see if this comes out. I can see that, oh, just a moment. No, never mind. I can see that this 21 here is twice of 42. I could cross multiply. You're going to get into hellish things. But instead, I'm going to say, well, if I multiply this 21 by 2, I get 42. But I have to multiply the top as well. So I'm multiplying this fraction by 1. So I get 4 over 42 on the left side, plus 10 over 42. And these are the same denominator now, so it's 10 plus 4, 14 over 42. And I can tell you that this is can be divided by 14. When I divide it by 14, I get 1. And this can be divided by 14. When I divide it by 14, I get 3. And I can see left side is equal to right side. Therefore, the answer is correct. Z is equal to 5. Be aware, sometimes you'll get an answer here that was also a restriction. Like we could come out with Z is equal to 2, but in the beginning we found out Z can't be 2, which means there's no possible answer. Just be aware of that. Sometimes you come up with an answer that can't possibly exist because of the restrictions. And the reason that we can come up with an answer that's part of the restrictions is we got rid of all the denominators. But in this case, 5 was not a restriction. We've proven that Z is equal to 5 is the right answer. That's one technique. Painful, I find it, personally. The other technique is we're going to go back to the cross factoring again that we had. So that was cross multiplying. I find it can get pretty annoying, pretty confusing. So we're just going to go back to the old technique. Oh, for some reason, it's not letting me do it. Go all the way to here. There we go. Z, we're going to go back to factoring. Z plus 2. Same restrictions. The restrictions didn't change. And then when I factor out a 6 on the other one, I get Z plus 2. There we go. So I've factored all I can. Just going to move this over. This is a technique I prefer. Is I can say, well, I can see a Z plus 2 here and a Z plus 2 here. So that's in common with the denominator. This one over here does not have a 6. And this one over here does not have a Z minus 2. Let's focus on this one. Remember when I said I can multiply any fraction by 1? It doesn't change. But I want a 6 in the bottom. So I'm going to multiply the top and the bottom by 6. You see, I'm going to multiply it by 6 over 6, which is 1. Whenever you multiply a fraction by 1, you're not really changing it. So 6 times the 2 becomes 12. And at the bottom, I'm not going to expand it. I'm just going to put the 6 beside this thing. So there, I've now converted this left one. Got to put the 12 up top. To a fraction that does have a 6 in the bottom now. That's why I multiplied it by 6 over 6. And that comes out as 12 over 6 times Z plus 2. This one, what's missing that it doesn't have on the left side denominator. The left side denominator has a Z by minus 2. So I'm going to multiply it by Z minus 2 divided by Z minus 2, which is the same as 1. Now at the bottom, I'm just going to not expand it. I'm just going to put it as a factor. And at this one, it's going to be 10 times that. And then don't forget the plus in between them. Plus in between them. There we go. Notice that I now have the same denominator, which means I can just make one big long bracket, and just use one of the denominators that I created. Notice that I can now expand here as well. 10 times Z, 10 times that, I get 10Z minus 20. Look at that. We got the same thing we got with cross multiplying, but in my opinion, a lot faster. So the top is 12 minus 20. I still get minus 8 plus 10Z on the top. Note that this plus is now essentially at the top of the fraction, not at the bottom. So I get minus 8 plus 10Z is equal to that. Boom, pretty good. And again, you just would do the same thing as before. I want to get rid of that denominator. So I'm essentially going to multiply it by the same thing, top and bottom, on the left and the right rather. And on the left, it's always just going to cancel. It's always just going to cancel. And on the right, you might have one thing canceling. And then this one doesn't have a factor. So it's just the same thing as that we had before. It's just this stage here I find a lot faster to see what's missing and multiply top and bottom by what's missing, top and bottom by what's missing. It's the same as cross multiplying, but cross multiplying can get awfully confusing. And then finally, let's see, there's another way of doing it. You could instead, no, this actually won't, this will just make it more confusing. So we won't do it. Yeah, I mean, yes and no. It's pretty much the same thing that I had. I think the method I just showed is pretty good. So we were down to this. There's one thing you can do first instead of multiplying by this one first. If you want to make your life a little easier, you can multiply both sides by this one first. It'll cancel on the right, and it'll get rid of this one on the left. I mean, it makes your last step a little easier, but it's the same thing. So those really are the two techniques that I would recommend for doing it. The other technique is nightmarish. It's cross multiplying, expanding, and adding everything together. I like the second technique I just showed you. So let's just look at one more. I won't have time to do all of them right now. There we go. Of course, it got blocked. Okay, you can see that this is already factored, this is already factored, this is not, and this is not. So in this one, we're looking for a number that multiplies out to 24, adds up to -4. So it's going to be a plus, or it's going to be a minus and a minus if it's going to multiply out to a positive number, which is pretty tricky to come up with -4. As the closest one is -6, and I think maybe there's an error in that one. And -4, but that makes -10. I don't think that's... So let's start by not... Let's just leave this top one alone for now, okay? Because we cannot really factor. But we can certainly factor this one because that's a square and that's a square. And it can be replaced with k plus 4, k minus 4. K plus 2, sorry. K minus 2. Okay, let's leave the top one alone because I don't think there's a knowable factor yet, so it'll probably come into play later. Let's focus on the left side. In this case, cross multiplying probably is the easiest way. But if I look at the left, simply because what I end up doing is cross multiplying anyway, because this one has nothing in common with this one. So I'd end up multiplying this one by k minus 2 and k minus 2, and this one by k plus 2 over k plus 2. But in this case, because there's nothing in common, it's the exact same as cross multiplying. So we would, our first step that I would strongly suggest is always put these things up top in brackets because it's like married. And this is going to be the long version no matter what. Cross multiply. So I got to multiply this by that. And I got to multiply the right one by this. And then the bottom two just multiply. So the bottom two, we're just going to keep it the same as that times that. And that's our new denominator. Okay, that's our new denominator. Up the top, really the only thing we can do is expand and then group. So it's really annoying. K times 4k, 4k squared. K times -1, minus k. -2 times 4k, minus 8k. And then finally, -2 times -1, plus 2. So we get this annoying thing. Where it can get complicated is if this is a minus, this minus is going to end up affecting everything. But so far, he's kept it plus. So far on the left, I have an expanded 4k squared minus k, minus 1k minus 8k is minus 9k, and then plus 2. And don't forget that this is 4k squared. So that so far is this left expansion. And then it's a plus symbol here. So it makes my life easier. K times k is k squared, times 2 is 2 plus 2k plus 1k, so plus 3k, and then plus 2. So I get k squared plus 2k plus 1k, which is plus 3k, and then plus 2. So I get this. And because it's got an addition between them, it's going to make my life a little easier for grouping. So if I look, it's going to be 4k squared here plus 1k squared here for a total of 5k squared. 5k squared. And if I look, it's minus 9k here plus 3k here for a total of minus 6k. And then if I look, it's plus 2 on the left and plus 2 on the right, so I get that. This is going to make my life a little bit easier. Okay, so that's what our total sum is here. This over this thing here. Now this is where the right side comes back. I want you to notice that whenever you have two things, this is essentially one fraction here, you'll find that when they have the same denominator, they just will cancel out. Here's why. So I would treat this whole left one as one thing, and I multiplied the whole thing on the left by the reciprocal of the denominator, which is this over 1. And if I multiply it on the left, I have to multiply it on the right. Now I want you to notice that since they're all multiplying here and all multiplying here, if there's individual brackets that match, they cancel out. But note that on the right side, it also cancels out. So that means whenever you have something equaling something else with the same denominator on the left and the right equation that are not adding up, they're just a fraction, you can just eliminate it. Now we simply want to get everything to the right side. So I have to subtract k squared, I have to add 4k, and I have to subtract 24 to get this all to be 0. So I have to subtract that, add that, subtract that. So 5k squared minus 1k squared becomes 4k squared minus 6k plus this 4k, because whatever I do on the right side, I have to do on the left side, becomes minus 2k, and plus 4 minus 24 becomes minus 20, and it's all going to equal 0. Complicated, isn't it? So it ends up being 4k squared minus 2k, so minus 2k plus 20 is equal to 0. Now that it's equal to 0, we can factor it. And before we're going to factor, if we want to make our life a little easier, we can say, okay, well, I can factor out a 2 here, a 2 here, and a 2 here. So I can factor out a 2, and I get 2k squared minus 1k plus, was it plus? Let me make sure it wasn't plus. I think it was minus 20. So it was plus 4 minus 24 minus 20. So plus 4 is minus 20. So that's minus 20. You want to make sure you get your pluses and minus. Is all equal to 0. And when I factor out a 2, I get 2k squared minus k minus 10. Makes it a little easier, because now instead of looking for something that multiplies out to minus 40, which is 4 times, or minus 80, 4 times 20, I'm looking out for something that multiplies out to minus 20, a little easier to work with, and adds up to minus 1, which means the factors are going to be very close together by 1, which means it's automatically 4 and 5. And because this is a minus, that means one of these is positive, one of these is negative. Because this is minus, it means this is going to be the negative. Which means, here's the problem, we got a 2 here. So we've got to do 2k squared. We put the minus 10 here, but this middle term breaks down into these two things. Plus 4k, and the reason I go with plus 4k first is because the 4 will match the 2 better than the 5 will. Minus 5k, because the 5 will match this 10 better than the other one. Minus 5k. So that means that these factors here will get written like that. The first term, so just leave this 2 in front. And just make a square bracket. The first term, I factor out a 2k from both. I get 2k. And in the brackets, I get k plus 2. These brackets should match. Here I have to factor out minus 5 because we don't want the k to leave with a negative. And I get 5 plus 2. Notice that these brackets here match, which means I've done it right. The other bracket is going to be whatever this is, plus or minus whatever this one is. So I got the 2, and I get 2k minus 5 and k plus 2. And if I wanted to make sure I got it right, I would expand this. That's 2k squared plus 4k minus 5k, so minus k, and then minus 10, which is what that is. So I did it right. So here's my final factor. Woof, a lot of work, wasn't it? Here's my final factor, which means either of those brackets, if either of those brackets is 0, oh, we forgot our exclusions, right? K can't be minus 2, k can't be 2. If either of these factors are 0, we set it. So this one to be 0 would be the opposite of this, minus 2. So k is equal to minus 2. Notice that this answer is not possible because it's one of our exclusions. So we set this, which means we ignore it, by the way. And then this answer we set to 0. We add 5 to both sides. 2k is equal to 5. And we divide by 2. K is equal to 5 over 2. Which means our possible answers are minus 2, which is impossible, and 5 over 2. Instead of what you would do is you would then plug it back into the equation. But instead of doing that, because this is fairly complicated, I'm going to instead take the original equation. I'm going to plug it into Desmos to see, and I'm going to use x instead of k. So I got, it's pretty complicated. So 4k minus 1 divided by k plus 2 plus, open brackets, k plus 1 divided by k minus 2 is equal to k squared, open brackets, k squared minus 4k. Remember, we couldn't factor that one. It wasn't until we expanded everything that we could, divided by open, and we'll say k plus 2. We'll do it like the factors. K plus 2 times k minus 2. So I'm going to put this into Desmos. Oh, notice I use k, and Desmos is annoyed. So I'm going to replace all my k's with x's. So Desmos is happy. And let's see, did I get it all? Yeah, this one's got to have x, and this one has to have x. Now Desmos is happy, and where it crosses the 0 is, so here's the two possible answers. Notice it didn't give me the minus 2 as an answer because it's an exclusion. But if I draw a line here, y is equal to 1, I can see where it crosses the red line. 5 over 2, or sorry, 2 over 5. 5 over 2 is the same as 2.5. So we got the right answer. 2.5 is the only time these equations will be equal. If you wanted to test it out, yeah, you could go through the hassle of plugging. 5 over 2 is the same as 2.5. So I'm going to just use, in this case, the decimal 2.5, okay? So 4 times 2.5 here is 10. And 10 minus 1 up here is 9. And 2.5 plus 2 is 4.5. And 9 divided by 4.5 is 2. 2.5 plus 1 here is 3.5. And 2.5 minus 2 is 0.5. Anything divided by 0.5 essentially doubles. So 3.5 divided by 0.5 is 7. You can check it out in your calculator. So I get 7 plus 2. And that's 9. On the right, a little bit more complicated because we've got to figure out what 2.5 squared is. 6.25. So I get 6 on the top. I get 6.25 minus 4 times 2.5 is 10 plus 24. Minus 10 plus 24 is plus 14. And 6.25 plus 14 is 20.25. At the bottom, k squared again is 6.25 minus 4 is 2.25. So I'd have to do 20.25 divided by 2.5. And hopefully it comes out as 9. And I get 9. So this whole right side comes out as 9. Since 9 left and 9 right, that means 2.25 is a possible answer. Notice we could never plug 2 into the equation, because as soon as we plug it in here, we get division by 0. The reason it came out as a possible answer is because when we got rid of all the denominators by cross multiplying, right, there's no longer a denominator, so there's no longer an exclusion. So it's not a real answer. That's why it can come out as an answer, but it isn't a possible answer.